We're going to talk about volumes of prisms and cylinders. First, volume. Volume is the amount of three-dimensional space that is contained within the interior of an object. So like if you were to take an object and fill it with fluid, or maybe fill up an area with cement or concrete or something like that. Formula for volume of a prism. Well, the volume of the prism is equal to the area of its base times its height. So where B equals base, or area of the base. And H equals the height of the prism. Okay. Volume of cylinder is also area equals, or volume is equal to base. Base times height. It's just in a cylinder where you have your base, it's always a circle. So when we think of area of the base, we can also just think of pi r squared for a cylinder. Now, when you're dealing with a prism, your base could be a rectangle, it could be a square, it could be a triangle, it could be a trapezoid, it could be a hexagon, a pentagon. We don't know, so we have to keep this as normal base. But here we can think of it as the area of the circle. All right. Okay, and one quick note about height. Height represents your right angle height. So like if you're to look at this, this could be your height. If you're dealing with an oblique cylinder, it's a right angle height from tip. Let's say you're like just right there on the edge and you drop a tape measure down. Okay, and same thing when you're dealing with a prism. You're talking about your right angle height of your prism. So, all right, so this would be my height right here versus on an oblique where you'd have to drop it down and it would be a right angle. Okay, and so we're talking about a right angle height. All right, otherwise that's called a slant height. Okay, well let's actually try to apply this here. Let's say the volume of each solid and round our answer to the nearest hundredth when necessary. So I look at this and it's a rectangular prism. Any of the bases or any of the faces could be a base because that's true in a rectangular prism. But I'm just going to use the bottom, what it looks like it's sitting on, as my base. So volume equals area of the base times the height. The base is a rectangle, so the area of the base is going to be 6 times 5. Not 6 times h, but 6 times 5. And times the height. Our height equals 7 right there. So times 7. Okay, well 6 times 5 times 7, that is 210 cubic centimeters. We're measuring 3 dimensions. Centimeter times centimeter times centimeter, so we get cubic centimeters. Okay, where we have a cylinder here, the volume of the cylinder is equal to pi r squared, the area of the base, times the height. Okay, and when I think of each of those things, I need to know, in order to find this, I need to know the radius and I need to know the height. Okay, whereas over here, I needed to know the area of the base, which was 30. And I need to know the height, which was 7. Okay, so if you think about what you need to know for each of your formulas and even write it down, that might help you out. So that'll be 5. And we're going to assume this is a right cylinder, meaning it intersects down here at a right angle. Okay, and that's a 4. Okay, so we're looking at substituting those values in. This is 5 squared times height of 4. That's going to give me 25 pi times 4, or 100 pi. And to the nearest hundredth, looks like we're at 314.16. And that is cubic inches. So that's a rounded amount. But if you wanted the exact, if they asked for exact, this would be your exact. Okay. Let's go ahead and try another one here. Notice on this one we have a triangular prism. We know it's a triangular prism because it has a bunch of rectangles connecting to congruent triangles. Okay, so there we've got it. So the area of my base in this one, well, that is 3 times, well, 4. So the area of the triangle, so 1/2 base times height. Okay, so that's 1/2 of 3 times 4. And now the height I'm talking about here is if I were to take just the base, the triangle. Okay, that's a 4 times 3. So this is what I'm talking about. So just the 2-dimensional base on it. Okay, so that is 6. So B is 6. Okay, whereas the height of the prism, well, this is the height of the prism right here. Okay, that's 3 because it connects the 2 bases. The length that connects the 2 bases is your height. So H is 3. And so if I'm using my formula for volume, V equals, well, in this case, it's area of the base times the height, which is 6 times 3, which is 18. And that's cubic feet. All right. Hey, one more. And notice this looks like a trapezoidal prism. So we have these 2 trapezoids, the one in back that's, you can see it back there, dashed, right? Okay. The way you find the area of a trapezoid, if I were to just take that trapezoid and draw it out up here. Okay. And these are congruent. I don't look exactly congruent, but it's okay. This is 8, this is 3, and it looks like the height of the trapezoid, the right angle, is 4.5. Okay. So if you're not familiar with the area of a trapezoid is equal to 1/2 base 1 plus base 2 times height. That is area of the trapezoid. I don't know why I wrote it off kilter like that. Okay. And so base 1 is 8, base 2 is 3, or vice versa. So we've got to add the 2 bases. Okay. So 8 plus 3. Multiply it by the height, 4.5. Okay. And we've got 11 times 1/2 is 5.5 times 4.5. All right, it looks like the area of that trapezoid is 24.75. Okay, that is B, 24.75. Okay, so now we're doing our volume. Volume is equal to area of the base times the height. Well, the height of the figure, remember, connects your 2 bases. So H in this equals 4. It's a different H than the height of the base. So that's going to be equal to 24.75 times the height of 4. So remember, your height of your prism always connects the 2 bases. 24.75 times 4 is 99, and that is cubic meters. Alrighty, let's talk about density. Density is the amount of matter that an object has in a given unit of volume. And density is equal to mass divided by volume. Okay, and one of my students the other day, Gunnar, kid in my first period class, he did a broken heart thing. He said for density breaks his heart. It's mass. You can kind of see the M right here divided by volume if you want to think of it that way. Might be a good way to remember it. Okay, and so if we're dealing with density here, a rectangular block of bronze metal, I know that it's not the color bronze, is shown below and weighs 1,794 grams. What is the density of the bronze? Well, density, again, mass divided by volume. So in this case, our mass is our weight. So this is mass. So it's 1794, and I'm going to write the word grams here, and I'll explain why in a minute, over the volume. Well, the volume of this, I have to calculate volume. Volume is equal to 9.6, right, times 3.5, so the area of the base times the height of 4.6. Okay, and so our volume in this one is 154.56, and that's cubic centimeters. Okay, so 154.56 cubic centimeters. And so when we do 1794 divided by 154.56, we get 11.61, round to the nearest hundredth, grams. Notice that's my label on top, per, that's my label on bottom is cubic centimeters. And so that becomes your label for your density, grams per cubic centimeters, because those were your labels there. You got your division in between. All right, some more real life stuff here. You're building a box to carry a robot to and from competition. The box must have a volume of 15 cubic feet. It must be 2.5 by 2 wide. What should the height be? Well, if you're thinking about volume of a box, that's a rectangular prism. So it's area of the base times the height. And the base, if you're looking at it here, you have this deal, and okay, we've got 2.5 by 2, so that the area of the base, okay, is length times width, so B would be 2.5, which in this case we would know that that is 5, and so we could say, well, that's 5. We need to know our height, but they do tell us the volume. The volume is 15. Okay, so we get 15 equals 5h. Divide both sides by 5. Our height would have to be 3. And we're measuring in feet there. 3 feet. All right. Got another one here. You're building a cedar hope chest. That's something that, like, you put blankets and different things in to give your mom for Mother's Day. You want the volume of the chest to be 96 cubic feet, the height to be 4 feet. What are possible dimensions of the base? Well, once again, we have a rectangular prism here, right? So we have this chest here. Okay, and we know that the height is going to be 4. Let's assume everything's right angles there. We know the volume is equal to 96 cubic feet. Okay, and so volume is equal to area of the base times the height. Well, we know the height and we know the volume. Volume 96. There's base. Our height is 4. Well, if we divide both sides by 4, we end up with 24. And label is cube, or 24 feet. Square feet would be our base. So in other words, you need to figure out the possible combinations that multiply to make 24. So if you think in this case, base is going to be length times width, because it's a rectangular base, right? We're looking at our length and we're looking at our width. Okay. Then you've got to say, well, if my area is 24, what two things will multiply to make 24? Well, you have options. You could have like a 1 times 24. You could have a 2 times 12, a 3 times 8, a 4 times 6. Okay, those are all possible dimensions. So if you're thinking in terms of feet here, right? 1 foot by 24 foot. 2 foot. 3 by 8 foot. And 4 by 6. Now, those are just your whole number measures. Obviously, there's an infinite number you could do, but let's just stick with whole numbers. Okay? Those would be your possible dimensions. Now, some would be more realistic, maybe like a 4 by 6. 1 by 24, maybe you're keeping fishing poles or something in it. So, all right. Let's go ahead and move on here. Similar solids. Similar solids, two solids of the same type with equal ratios are similar solids. Okay. Equal ratios of their corresponding measures, for instance, radius, height, width, any linear measurement. Okay. A scale factor K is the ratio that you have of the corresponding linear measures of the two solids. Okay, so when you're dealing with linear, you're dealing with K. When you're dealing with area, you're dealing with K squared. When you're dealing with volume, volume of similar solids, the ratio of the volume of the two similar solids with scale factor K is K to the third power. And the best way to think about this, volume is measured in like cubic centimeters, cubic feet, whatever measure you're using there. And so when you're using a scale factor, it's cubed. Just like area, for area for similar solids would be squared because you're measuring in square feet. And if you're just dealing with linear measures like length, it's just K to the first power. Okay? And so if I'm given two similar solids and one's smaller than the other, then you could, and you know the scale factor, you can figure out the volume of the other. So in this case, I know that my scale factor K, since these two prisms are similar, scale factor is 6 to 4, or 4 to 6. It doesn't matter which one you use, right? So K is 6 to 4, which, by the way, can be reduced to 3 to 2. K cubed, the volume, so this is our linear, like our sides. K cubed, our volume, right, is equal to, well, we've got a cube 3, so 27. So if you think about it, 3 cubed over 2 cubed, which is 27 over 8. And if I want to find the volume of the smaller now that I have a volume ratio, I can actually calculate and compare the volumes of the solids here. So the volume of the bigger, which is up here with 27, is 156. Volume of the smaller, and since 8 is smaller than 27, that's down here, is V. So to solve this proportion, we cross multiply. 27V is equal to 8 times 156, also known as 1,248. And divide by 27, you get the volume of the smaller is 46.22 cubic inches. There, we got it. Okay. If we have cylinders, it works the same way. The volume of the larger cylinder, though, is what we're looking for. We're going to leave our answer in terms of pi. So K, our linear ratio, is 4 to 2, which could reduce to 2 over 1, which would mean K cubed would be 2 cubed over 1 cubed, also known as 8 over 1. And then we can set up our proportion. 8 is to 1 as V is to 24 pi. So we've got, since the larger is the 8 up top, the larger number, and we're looking for the larger, it's here. Smaller is the 1, and the smaller volume is 24 pi. So keep those on the same level. So 8 24s equals 1V, right? So V equals 192 pi cubic centimeters. All right. Well, we got one more thing here, and it's actually looking at a composite solid. That means solids that were more than one solid that we're dealing with here. A square prism, that's an important piece. That means the base is a square. So look at that, that's 12. That means this is also 12. With a cylinder cut out the center, find the volume of the figure. So find the volume of this without the cylinder in the middle. So we need the volume of the square minus the volume of the cylinder. The volume of the square is going to be the area of the base times the height. And the volume of the cylinder is going to be pi r squared times the same height, right? Looks like they're the same, going the same height there. So the area of the base, well, our base is 12 by 12, or 144. So B equals 144. Our height is 3. And our radius, the other measure we're using, is half of 8, which is 4. Okay, so just substituting pieces in. 144 times h, which is 3, minus pi times r, which is 4, squared times h, which is 4. 144 times 3, or 432. And 4 times 4 times, oops, I don't think our height is 3. That's my mistake. 4 times 4 is 16 times 3, or 48 pi. Well, if they want the exact answer, that's it. You can't combine the 432 and the 48 because 48 is counting pies. It says it doesn't tell you to round it. I'm going to go ahead and leave it like this in one format, and I'll also round it. So this would be cubic centimeters, mind you. Okay, so maybe let's okay, there's my exact. Now, if I actually rounded it, that would be 281.2 cubic centimeters. All right, that's all I got for you. Good lucky.